Okay, welcome. This is part 2 of the video of solving quadratic equations using quadratic formula. In the previous video, we looked at vocabulary, and sorry I kind of ended that abruptly. Still working on learning to make videos, so just bear with me. So let's quickly review the vocabulary. Again, this is 4.8 in your book. And our vocabulary is basically standard form. And I said it's very imperative in standard form that you have terms in descending order, but I didn't tell you why. So as we look into the quadratic formula, we're going to see why that is so important. So again, standard form must be equal to 0. So all the terms on one side, we usually say the left, and we must have our terms in descending order. That's x squared followed by x followed by the constant. Okay, let's look at the concept. This is the quadratic formula. It says for ax squared plus bx plus c equal to 0. So there's the standard form again. So we're saying if we have this in standard form, our quadratic equation, the value of x is given by, so this is the then part. If it looks like this, then we can say this. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Or a, b, and c are real numbers. So one more time, if it's in standard form, then we can say we can solve for x by using this formula. Okay, so our techniques of solving, we have factoring, our quick and easy move. If there's no linear term, we can square root both sides. We have completing the square, which gives us the option of taking any quadratic equation and making a perfect square, again, so we can square root both sides. And now we have this formula where we simply have to write the equation in standard form, identify our a, b, and c, and just simply substitute them in the equation and simplify. So let's take a look and see how that's done. Here's the first example. We have to solve x squared plus 3x is equal to 2. Okay, and the first thing we want to do is write in standard form. Now it doesn't really matter what method we're using, essentially, except maybe the square root method, but we always seem to want to write them equal or set them equal to 0, right, in standard form. So let's go ahead and do that. A simple, let's subtract 2 from both sides. Remember 3x and 2 are not like terms. So please don't try to combine them. There we go. X squared plus 3x minus 2 is equal to 0. Now the first thing I would look for would be factoring. But as I look these over, I can see right away that this cannot be factored. So I'm going to jump to the quadratic formula. All right, so our next step after standard form is identifying our a, b, and c. Now this is where standard form is imperative. We have to be in descending order. We have to be all on the same side of the equal sign. Otherwise, we will mix up our a, b, and c. So our a is the term in front of, or the coefficient in front of the x squared. So in this case, our a is up here, and he's going to be 1. Our b is the coefficient in the linear term. He will be 3. And our c is our constant. In this case, don't forget the sign. He's negative 2. So I'm going to go ahead and circle him so we don't forget the sign. So we have the 1, the 3, the negative 2. Okay, our third step, simple substitution. So please, oh please, write down the equation. Okay, the more we write it, the more we will have this thing memorized. And even say it as you write it. This is x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Now with a simple substitution, we can see x is equal to the opposite of, let's plug in our b. In this case, b is 1. Opposite of b plus or minus the square root of b squared, and again, b is 1. Loved ones, they're easy to do simplification with, minus 4 times a times c. In this case, 4 times a times c. A is 1. B, c is negative 2. And this is all divided by 2 times a. Okay, so as I look back at my substitution, the first thing I notice is I did a non-example. I actually substituted in the wrong letter. So let's back up. If we look at the numbers I'm supposed to be substituting, it's supposed to be the opposite of b. Now what is b? Well, b is 3, and I substituted in 1. So a little quick error I made, and that's okay. I'm just going to simply pull this out. We're going to talk about it real quickly again, and I totally apologize for that. B is 3, so we want the opposite of 3 plus or minus the square root of b squared. Again, that's 3 minus 4 times a. A is 1, and c is negative 2, all divided by 2a. That looks better. Again, I apologize. Hopefully that didn't mess your notes up too bad. Okay, once we've done the substitution, lastly we simplify. Okay, most errors in the quadratic formula are made in the simplification of what's underneath the radical. So I'm going to simplify that first. I'm going to do some side work. I'm going to say, okay, 3 squared minus 4 times 1 times negative 2. Well, that's simply going to be 9. Negative 4 times 1 times a negative 2 is a positive 8. It's simply going to be 17. Okay, again, I suggest we do this first because that's where a lot of the errors occur. Okay, substituting it back in, this is what I'm getting. So I have x is equal to negative 3 plus or minus the square root of 17 from here, all divided by 2. Now when I look at my answer, I'm looking for any more simplification. Okay, so I simplified under the radical. I did the 2 times 1. Now the last step is to look, can I simplify my radical any more than this? 17 is a prime number. You cannot take the square root of it. So at this point, we are finished. Okay, go ahead and make sure you get your notes copied down. If you have any questions that you didn't get the first time, listen to it again. And if you still can't get it, jot it down on the side. So again, I apologize up here in the substitution. I substituted in my A instead of my B. Make sure that's fixed. And we will see you in class. Thank you.